Okay, so we are live for Admin Code Day 15, and last we left off, I had to leave a little bit early on day 14, so I'm just going to finish this one up. Um, I think it's pretty approachable, so I have this is one where we're pushing these rocks around, pushing them all north. The brown ones can roll up until they hit these pieces, right? So we push them north, west, south, east. That's a full cycle, so I have a full cycle working properly. And now we have to compute what happens after a billion cycles. And I'm pretty sure there's a cycle in some point at which like the total load repeats itself. Um, or at least the state of the stones themselves repeats. So that's what I'm gonna look for. Not the load itself, because I don't know, maybe two states have the same load but aren't actually, it's not actually a repetition because they are not identical. Alka, welcome, welcome. um, yeah, this was they're starting to get a little bit more challenging. Do you think you'll return to this one, Alka, or are you calling it? Um, what do we have? So we have working cycles. I'm happy with this. That looks as it should. Uh, we had some cycle detection that we had started writing somewhere. Okay, here the cycle length. I'm not actually sure if I like that. What I think I'll do instead, I'm not even gonna do it on loads. What I do instead is I suppose take hashes of the rounded. So take all the cycles, and these are all sets of points. Take hashes and find a hash that has already been seen. So let's cycle. We'll say just hashes. That map, that hash code. Okay. Oh, that's fair. That's fair. Very understandable. Okay, and then we're gonna do, what is this? A scan left. It can early terminate. Yeah, there's like an ongoing state. Um, Hashes that, let's start with a fold left. Fold left. So you have a set.empty of int and case scene hash. If scene and hash, then return else scene plus hash. Oh, yes, this is this is an early termination. That kind of sort of works, but not really. Just bear it. Do you remember when we got a Wii? It was released in 2006, but I remember getting one Christmas 2008. I feel like we got it the very Christmas it was released. 2006, I think makes sense because like I was entering high school. That's before I went into high school, maybe. Maybe it's 2000. It was not 2008. Yeah, 2007 was my first summer after high school. So we got it was in 2006. That was my freshman year of high school. That's my frame of reference. So I believe 2006. Um, Little diversion there. Okay, so this is the idea, but what we're gonna do instead is like calculate scene hashes. So this can be a scan left. Hashes on scan left. Um, and then a scene hash. If scene and the sub scene will grow. Um, I mean, we just might return like waltzes in here. So scan left has a state that's growing. Um, yeah, so we're just going to return scene plus hash, add the hash to it. Wait, what does this end up? No, this just keeps getting new hashes. I guess at the point at which the hash doesn't grow. Yeah. Or we could also like do the Boolean. Um, maybe, maybe what I want is an unfold. No, we're doing this. Hashes. Okay. And then now we'll take clean hashes dot zip with index, and then we're gonna find or we could do like an index where no, we do need to reference index, so we'll do this. Hashes index. Whoops. So hashes and index. And that's not the function I want. What I want is something more like hashes dot size is less than index. We're going to do a collect first. The first case where hash dot size is less than index, and then we return that index. So case if hashes dot size is less than index, return index. Val, this is the repeat index. And let's see if that just works. It might be a little bit slow. I have a few ideas for optimizing. One is faster to implement. Not cycle length. Oh, okay, yeah. Oh, this just works. Okay. Oh, this is still on the example data though. Okay, well, let's make sure we can get the example then. So we have the index where things repeat, right? Okay, with that, what can we do? Uh, so I guess we could take cycles 11. So cycles repeat index.get val. This is like the first repeat index. What is this? Second repetition. Repeated set, a repeated cycle. Val first appearance equals hashes dot index index where. Okay, so that's the index. Val I equals that, and then we take cycles I. Okay, and then now we have the cycle length equals repeat index dot get. Yeah, minus hashes minus first appearance. Oh, the index of the first appearance. Yeah, we don't need the first appearance itself. Okay. No, we just want, yeah, we want the index. We're going to get an index. Okay, now we can do this. Um, First appearance. There we go. There we go. Okay, so cycle length is 7. And then now we take 1 billion. So 1 mod cycle length. There's a little bit more to that. We need to add the first appearance. So plus first appearance. And then mod cycle length. Does it add or subtract? Okay, like if we appear right after one of these. So we have a cycle length of 7. So like we would get something like 5, right? 5 being the same as 10. Or 5 being the same as 12. Because we have 4 and 11. Okay. So I think we subtract first appearance. Hold on. So 1 billion is going to be the same as, I suppose it's the first one past the first appearance, right? So 1 billion, it is still going to be mod cycle length. Let's start with what 1 billion mod cycle length is. Okay, 6. And let's say we were starting from the beginning, sure. Then that would be the 6th element before it repeats. Now let's add 1 before we start doing the repeating. Then 1 billion should also increase by 1. Yeah, so this is plus first appearance here. Okay, and then we get loads. Well, this is a congruent index, and loads of the congruent index. That should be, okay, here you get 69. We should be getting 64. Loads, 100 for each print line. Let's look at that. And my congruent index is 10. So we start repeating. Where's the first appearance? At index 4. 0, 1, 2, 3, 4. This is where we really start repeating. This third 69. So 4, 5, 6, 7, 8, 9, 10, 11. Apparently, yeah, this is where it starts repeating. And then there are only 2 groups of 69s. Okay. 0, 1, 2, 3, 4, 5, 6. The answer we should get here is 6 for a congruence index. So this one here, let's check if that equals 6, right? Right now it is, what is it? It is 10. Okay. 10. It should give a value like 6 or 13. So how do we get there? I think this is where we can just do a little bit of guess and check, right? What if this is a minus first appearance? Nope. So this here is just 7. What if it's like a minus first appearance in here? What if it's a plus? Now those are getting me 6. You know what? I already did this math before. I don't want to repeat it right now. Let's think here. So tends to the cycle height times the number of cycles. Um, yeah, this all right here is cycle detection code from day 17 last year, which had the same kind of thing. I think it's like a lengthier approach. So here's 1 trillion. Oh, is 1 trillion. Wow. Um, the extra. So trillion minus cycle start. Um, hmm. Why did I do that? So modulo the period, the cycle length. Okay, you know what? That's fair. I see where that's going. And you take like, okay, you have to add to that 1428. You have to add whatever it's going to be modulo. Yeah. Okay, so the extra bits. We're going to take 1 billion minus the first appearance modulo cycle length. So we're going to be 2 past one of the cycles. Right. And then we're going to add that to first appearance. And that gets a 6. Okay. And this is our congruent index. Well, congruent index. And let's just try that for now. Load a congruent index. This is our answer. Okay. Yeah, I'm just gonna straight up try that on the main example and see what we get. That might run out a little bit. So this is where we think about optimizing the cycles themselves. Um, and honestly, what I could do, let's cancel this. I'm just gonna have this run in the background while I optimize, kind of multitask a little bit. So, what is it? Ends to all this stuff. Let's comment it out. Clean hashes, repeat index. Not actually using anything yet until we try to find the first appearance. So repeated cycle, repeat index. Okay. Comment all of that out. And we're going to cancel this evaluation of the worksheet. Oh no, how did I do it? Ah, metals, cancel compilation. Will that work? Oh, okay. Oh, right here, right here. We can cancel that. No, cancel that. And we're gonna copy this into day14.scala. Have that run in the background. Maybe that'll complete before we wait, did I do it? Day14.scala. Okay, and we get an ans to put this all in the package. Package 2023 day 14. Um, can we should be able to do all of this. That should be legal. But what we could do is like at def or at main def day 14 and just put everything in there. And then print line ans to delete all that. SBT and then run main and see what it gives us. Okay, let's go in. What is running in the background? Let's switch back to the day 14 worksheet. I'm going to change this back to the example. We want it to be able to run. Leave all that going. Make sure we're still getting the same answers. So this should still be 136 as a first test. And this roll function. So one problem here is we do a lot of sorting first, because we move the one that's closest to the wall first. That is unnecessary. We're just gonna do like start dot fold left. And this roll function. So take while not occupied. I think we're gonna take while not a square, and then not filter not occupied, and then two lists elapsed option getter else. So I think that should still work, and that's significantly more performant because we're not sorting all the time. That was so easy to write. I shouldn't have let that other one run in the background. In fact, I'm not even running in the background. You know, if I needed to, I'll make this run in the background. So I'll make that same change. Blah, 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 while I'm doing an even better optimization. Okay, here we go. Here we go. So still taking a little bit longer. I'm gonna copy this over day14.scala. It seems wait, why is this not loud? This is Scala 3. This should be fine. Okay. Well, let's start by fixing this code. And then we can figure out why that's not working. Git ls files xrx fgrep. at main. All right, I've done this in the past, so day23.scala 2021 has that, and it works fine at main def day 23. Maybe SBT doesn't have the same issue with it. Anyway, wait, did it give me an answer? Are we still? Oh no, this is still running. Okay, it's been running for a minute 30. We might need to be more clever about our cycles themselves. I wonder if I should say the might run out of memory. Oh, did it start reevaluating again? Okay, we'll check with SBT. Compile. Um, that main def declaration method is not. This is a Scala 2 error, right? That is a Scala 2 error, not a Scala 3 error. I don't know. Let's try to define an object with Scala 3 syntax. Object def main hello world. Sure. It does not like that. So somehow it's using Scala 2 for compilation here, and I don't know why. Okay, so we're not going to run anything in the background right now because I don't want to be debugging my compiler settings. I mean, we can take a look. Build.sbt, Scala 3 version. Right. That is the version we're using, is 3.3.1. I don't know what to say, except, you know what? Here's a solution. Day 14. We can just put all of this stuff into like the hello world this comes with. I don't know. Yeah, I've never like overwritten this. And now does, what are these problems with? Like main.scala? This should be fine. Whatever. We're not doing that. Clearly we need to optimize, so we're just gonna optimize. Let's see, and we're just gonna remove those changes we added to main so that our project can continue to compile. I don't know what this is about. 14.scala. Make sure this whole thing is out. That way we can compile. And our editor is happy. So this, we're gonna cancel that. We're gonna set this back to the example. Cancel. Okay. So we need to optimize. We have 15 minutes to optimize. I had an idea. So for each of these rounded, we can get like the area below that needs to be checked for points. then we can just take all those points, count the number of rounded walks, and fill it in appropriately. Val area below. So squared map. So we have a square point. Okay, right. Take well area contains take well not squared. Yeah. So these are all of the points. Points. And this only needs to be computed once instead of like on every roll. And then so area. Let's see. Or rather, we take the point. So square point goes to area dot bounding of those points. I don't have any. Let's do like point set to set. Okay, points. Oh, we don't want the last option. So we're just gonna like to set right here. That's a problem. Min. Where does min come in here? Wait. Empty dot min. Iterable area dot bounding. Okay, so if there's nothing below it, okay. So we're gonna do like if points dot non-empty, then that else area. Is there dot empty? I don't believe there is. Wait, really? No, nope. That's not what we want. Area, let's say 0 to 0, and then or 0 until 0. Empty ranges 0 until 0. Okay. Great. Identifier expected, but that's perfectly fine syntax, right? And we're gonna put all this in a map. So map from, and what is this? This is a map of point to area. Yeah. Wait, that's valid. Why is that taking an issue with that syntax? Probably because of something else entirely. And like I can write this square point height value equals whatever that is. Like that's valid code. Val f equals 13. Sure. We can do like a print line 13 or a print line f, whatever, and then there's a set of points. my worksheet is not currently computing anything. You know what? We just restart this real quick. I think it's just fritzing. I don't know. I really don't know about that yet. Um, okay, so there, it evaluated that, right? This works. That's perfectly valid code. Now let's get this to compile. Map square point. And in this case, it doesn't like that syntax. Hmm. Um, I don't know. That's totally valid syntax. This is not a helpful message either. Okay, what we're gonna do, let's just like change the syntax. Maybe we'll at least get better errors. Uh, oh, it probably has something to do with this. Maybe it has to be ref in parens. Okay, map of point and area. I'm gonna add a marker there. So this is like, this braces free syntax is new, and that's not a helpful error message. So I'm gonna report that. Unhelpful syntax error message. Because the syntax error was all the way in this if else, so it had to be in a paren. Uh, and instead I was getting a wild message like up here about needing to close that line. But I learn as I go. At least I know what that weird error message means now. And we're just gonna let Copilot do some work for us, turning this into area right. Well, area. Yeah, we could call this area south. So area south, val area north, val area east, val area west. Okay, now in our roll method, I'm just gonna blip, blip, blip. We can just use those areas. So depending on the direction, I'm gonna do like a dir match. And if it's east, then we take area east of that point. Well, let's see. No, no, no. We are moving. We are rolling east, so we want the area west of these points. Area west at this point. Um, and we're just gonna just take like, I suppose I could iterate over those points instead of iterating over all around it and filtering that out. I could round and filter that, or yeah, that points iterator, not filter rounded. And then then we have the size. or we just can count the rounded. And then we take p dot west and I guess we take a line p dot west or an interval. No, lines work with this. So p dot west to p dot west repeat. So this is going to be like an off by one kind of deal. So we're going to take size and then I guess I'm going to go east first. P dot east. And then west repeat. Size. Or honestly, it might just be simpler. Whatever. That does work. That points. That has a points method, right? Okay. And then rounded. Oh, well, moving points is this. And we have this count. Oh, size is not defined. So val moving count equals moving points, that count rounded. This I think needs to be we're gonna make that a set. I guess I could intersect and then take the size. Yeah, that's probably gonna be the most efficient. So moving points dot intersect. Rounded dot size. Moving count. What we could do, I'm just gonna do this. So 1, 2, or let's see, p dot x p dot x plus moving count, or this is gonna be an until. And since this is moving east, it's gonna be a plus. Wait, well, new points. And then what we could return is rounded dot diff moving points, new points. And now we'll just let Copilot complete this stuff. We check the area north, py until p. So we're pushing south, so we need to check the area north. This is actually going to be py minus moving count by -1, because moving north is moving negative. Okay. Let's see if it gets west right. Okay, it gets the idea. And then north Should get that right. All right. So if that's good, we should still be okay. We're getting the right answer, right? And not for like any. Is it still evaluating properly? It has some compile issues right now. So roll. Oh, this should be roll all. Yeah. Okay. Let's take this out. Okay, we have a starting set of points. So instead of using rounded, we should use start. Um, and we're gonna do this for all of the squared points. Squared dot uh, and then we have to combine these. We still have to combine these. So the end goal is like a set of points. Hmm. Okay, so I guess we do that in here somewhere. So squared dot iterator. For all of these, we have to get like this can be a fold left. So we can have start and then rounded in P. That will make it work. Yeah, okay. Exactly. This is the same code here. Um, yeah, just copy, paste that bit a few times. You can tell I'm like desperate and hurrying when my code starts looking like this. Like I know in my mind that developing cleaner is always faster, but that doesn't always like stick in like my guts, you know? Okay, this is working. Is it working though? Let's look at our ands one. Now ands one. 122. Now we're slightly off. Let's look at these cycles, see what's happening. Oh, that looks really weird. Okay, so we debug this new roll all method. Do like a roll all north and see what that looks like. So let's do like a show. Roll all rounded up north. And that's patently not north. So what happens here? We match on direction. We go to north. And square dot iterator fold left. So we have our start. Our starting set of rounded points. We have a bunch of points that are moving. Wait, honestly, we just need all these union points. We don't need to like be diffing out stuff. We can just take a union of all new points altogether. So this can be like yeah. Oh, yes. Let's do that. So we're gonna take that empty of the points, and this is now just our accumulator. And all these mentions are rounded. It would be start. Right? Start. Where are all the mentions are rounded? Um, and these are all accumulators now. And at the end, we just act dot union new points. That empty point. Okay, and we just empty point. Like this is really code that should be a little bit more generic, because in this copy paste, I'm gonna make a mistake. I'm calling it out right now. Um, mm, okay, so that compiles. It's so much longer than my naive version. Mm, and now what happens when you roll all north? Well, we're still getting this, right? And wait, we're getting a different answer now. Getting 53. Um, oh man, 20 minutes left. If I don't finish this will be the first time I didn't finish an admin of code problem before the next one dropped. And that will be a disappointment. Run east, e until p.x. Let's just look at the north. We're just looking at north. Moving points are area south p. We can check that. So area south. Let's just show our original. Show rounded. Okay, so there's like one at x 0, 1, 2, 3, 4, 5. So let's try area south of point 5 across and 0 down. And that's the range 5 to 5 and 1 to 1. Okay, so that range is wrong. No, that is right. Just one square. Okay, let's look at 1 down and all the way across. So let's area south point 1 down all the way across area dot 8 border 9 to 9. So if you stay in column 9 and go down 2 to 4, so 2, 3, 4. So that bit is accurate. And if we were to print like whatever the moving points are, so where's the one where we try? Here we go. Show all rounded, and you push north. I could print what's being moved and show where they're moving to. So py we have p.y. Oh, we don't want p.y. we want the point above. So north, uh, we are moving north. P is our block. So we want the thing that's south of it. P dot S dot Y to P dot Y, and then to look south, take moving count. Let's see if that works. Um, that looks good. That looks good. That looks better. It also appears like some points are missing from that. Do all these rounded points cover everything? Oh, yes. So we don't just do it on all those rounded points or squared points. You have to do everything like above here too, and clump those up. Okay, yeah. Let's just add that to our area ranges. Um, let's just add it to squared. So val, these are the real ones, and val equals area dot band one dot, and then val outer, plot that, and then outer dot top border dot points. Yeah. Okay, and all that, I'm just gonna do a big two set on it. Um, and anything that has nothing below it should be filtered out. I think we can make this an option. So val areas, I'll do that. Then we filter them for this. So option dot when points dot non-empty, take the area, the bounding area of those points. Area. We're gonna option this whole thing. So option. There we go. So this is the areas. Just gonna take like areas dot flatten. Okay. And you have to rewrite that everywhere. Copy paste development. Val areas was that. And we just put that everywhere. Val areas. Val areas. Dot bot border. There we go. What is this? These are seeks. Combine those. Doesn't like the two set. Oh, right, we have to do um yes, that is that. Then here we do real union fake. Okay, okay. Great. Now this code, it shouldn't even be square.iterator. Let's do like square.iterator. No, no. We're taking area south. Yeah, area south. Dot map. Case the area. No, we're gonna fold. Yeah, fold left. Set.empty of point. And now we have an accumulator. And a point in an area. And we take a.points iterator. Okay, and now let's see if this looks correct now. Roll north. Perfect, 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 perfect. Do that everywhere. What is it? So like this becomes A, and this here becomes B and A, and this becomes area east. Area east dot fold left. And I'm just gonna delete the other two and have Copilot do my copy paste for me. Paste through dot east. Okay. So let's just check if our cycles look good. Let me pull up the admin of code. So after one cycle, oh, that looks wrong. Oh my god, I'm worried I don't have time to debug this. But north looked good. Val ands 1. That's the right answer. So this works for north. We just need to get it working for the other 3 properly. Okay, so for this one, we did p.s.y. That's key, and that hasn't been copied properly. So for this becomes p.east.x. Oh, p.x. Well, 2. X by -1. Okay. And this becomes p.west.x to p.x plus moving count. And this becomes p.north.y to p.y minus moving count by -1. Okay, let's check if our cycles are correct. So after 1, oh, what happened to our rounded points? Or squared points, rather. Are we using squared points where we shouldn't have? Place rounded somewhere. So these are our squared points. That shouldn't change anything. Let's print the original. So show rounded. This is the original. The original is fine. And let's show what happens when we roll them all north. That is fine. Okay. Let's just show each of the other directions. South, east, west. This is south. That looks good. East. Okay, east and west have issues. It looks like they go on top of where the points were, squared points were previously. So that's probably happening in here somewhere. So if north and south are fine, let's look at east. So B dot west. If you're looking west, this should be the minus by -1, right? And this should be plus. Good morning. I had to stop early, and so I'm trying to finish part 2 like right now in the next 8 minutes. And I think I got this is just like optimization to make sure. But I'm doing like the period detection, and the period detection code works. So as long as this becomes more optimized, then I should be good, right? Okay, let's check. Okay, our moving east works. Moving west works. Moving east. Moving west. Okay, so our cycle should look good. We are ending up with more and more pieces. Oh, no, 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 no. Okay, well, let's do count that dot size. Okay, so which one has an issue? That size. 59. South is problematic. East. I didn't write general enough code. That size. West and south are both problematic. Okay. So north and east are fine. Let's put. Okay, if east is fine. West. Oh, there's a -1 here. That shouldn't be. P dot east dot x to P dot x plus moving count. Okay, and south. Be minus moving count and then by -1. By -1. Okay, that's all 18. Do our cycles look good? Great, that looks good. Now it's getting the answer for part 1. Let's just run this for part 2. Yeah, this stuff here doesn't matter anymore. Now adds 2. Let's see. Is it loading? It has. Yeah, we don't care about that. Oh my god, there it is. Just in time. Oh my god. I have never not solved an advent code problem before the next day dropped. So I saw that claim. Val ends 2, line 3102. Line 3. Oh my god. If you're here in chat, I need to hear a cheer for that because that felt good. That felt good. Okay. Thank you, thank you. Solved day 14, part 2, just in the nick of time. When do you get push? I don't know, maybe force release. We don't know what's in there. Okay. Ah, we can relax. What a warm up. What a warm up. Oh my God. Hey, Ron. Welcome. Welcome. Thanks for the chat. Oh, back to the calendar. Um, yes, I know I can turn the table. That was my first approach, and I was doing my rotation. The thing is, I have a set of points rather than like a 2D grid, and I have rotation code, but my rotation code didn't anticipate that like your center, the point by which you might rotate, might not be like an integer vertex. And I started writing that. And it was taking too long to figure out the math properly. So I did this pilot driven development. But rotation is exactly the thing I wanted to do at first. This will be a great candidate for cleanup. Oh my God. Okay. Well, I finished. 23,000. Yeah, to 16,000. Yeah. So these are the two nights when I wasn't able to finish. Last night, I had to stop an hour in. I had a quick emergency to deal with. Someone was sick and needed my care. But they're a lot better now. So hopefully I'm not getting sick. I'm on the leaderboard, so I must have taken a hit. I'm still holding second on the Scala leaderboard, and on my personal leaderboard, I'm still holding fifth. Okay, but the gaps are getting bigger. Jan Pieter here is my main target on both these leaderboards. And I think I can get him. I just need a good break. I ride this wave here. Let's get my day 15 worksheet ready. Let's see, it says day 15. Input, deadlines to vector, sure. Oh, nice. Nice. You link that to me. I'd like to take a peek. Oh man, I'm gonna put on some music because we are back into like relaxation mode. 20 seconds in. I know I could solve it. It wasn't a hard problem by any means. It was just okay. Lens library. Ooh, interesting. So comma separate inputs of some sort. They seem to be in equations. What's the question? Run the hash algorithm on each step. What is the sum of the copied result? Oh, this is an interpreter problem. Okay, we can do an interpreter problem. You pass through outside doors. Oh. Apparently unaware that the concerned reindeer, blah, 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 blah. The hash algorithm is a way of turning any string of characters into a single number. Okay? To run the hash algorithm on a string, start with the current value of 0. Okay, so we have like a state of value. Determine the ASCII code for the current character of the string. Increase the current value by the ASCII code you just determined. Set the current code. Okay. So that is a little step. Um, so def, I guess we're just gonna call it this hash. Yeah, I mean it is hash code. So string and then returning an int, and we're gonna fold left, string that fold left 0, and then case ack character. So what do? We take ack plus char dot to int. Let me just make sure char dot to int is what I think it is. So like a dot to int. Yeah. Don't need to do a mod. Increase the current value by the ASCII code you just determined. Set the current value to itself multiplied by 17. So this times 17. And then remainder divided itself by 256. Okay, and then so mod 256. Fold left, let's spell that right. Okay, so we have our hash. Let's see a test. Rn equals 1, hash that. I don't even think I really need to test this, but that becomes 30. Okay, and input that's split commas that map hash. And what do we do? And then dot sum hash. I'm gonna hash a thing and then do too long, and then sum it just in case. Input. I think it's one line. Is it one line? Let's input that size. Okay. So we just do input 0. Okay. 459. Wait. 495972. Done. Continue part 2. The page confirms your hash algorithm is working. Great. What goes on to describe a series of 256 boxes. Number 0 to 255. The boxes are arranged in a line starting from the point where the light enters the facility. The boxes have holes that allow light to pass through. There are lens slots. Okay. The side of each box has a panel that opens to light to insert or remove the lens that's necessary. Along the wall. Wait, I just want to know kind of what the goal is here. What's the focusing power? Total focusing power for each of these. The end of the RN. Box. Okay. Okay. So there's lens slots, focal length ranging. The book goes to explain how to perform step. Process calls the hash map. Each step begins with a sequence of letters that indicate the label of the lens on which the step operates. Okay. The result of running the hash algorithm on the label indicates the correct box for that step. Okay, so that gives you the box number, I suppose. Well, I guess, this is, well, ends 1 equals that. But this, I don't think we need to do a too long here. Let's just do this. Val labels equals this. So this is a list of strings. Val hashes equals labels that map hash. and then ans1 equals hashes.sum. The label will be immediately followed by a character that indicates the operation to perform, either an equal sign or a dash. Okay. If the operation character is a dash, go to the next relevant box. Okay, so this one here, rn equals 1, has a meaning. The label tells you the box, run hash in the full label, either an equal sign or a dash. And if the character is a dash, go to the relevant box and remove the lens of the given label. Okay, so you have a box of lenses, and it has an initial state. Okay, it will be followed by a number indicating the focal length of the lens that needs to go into the relevant box. Be sure to use a label maker to mark the lens, the label given in the beginning of the steps. You can find it later. Two possible situations. If there's already a lens in the box with the same label, replace the old lens. Okay. If there's not, add. Okay, yeah, this is kind of like a hash. This is a hash map. So def step label string. And then we have state, which is a box of slots that starts. Keep a lens correctly positioned. Have each box has a panel, and does the box start empty? So here's an example. So box 0, after rn equals 1, then box 0 has rn 1. An explanation. All 256 boxes are always present. Only the boxes that contain any lenses are shown here. Within each box. Okay, so we have boxes. I guess this could be like a vector. Within each box, lenses are listed from front to back. Oh, a vector of a string. And we return more boxes after each step. Don't completely understand this though. Oh wait, which part is the label? Is by focal length from 1 to 9. So I guess just the RN part is the label. Match. So let's say we have it knows a little bit about it. So there is I guess this is the label, the actual label. Okay, so I guess these aren't like the labels, but the steps. Instructions. What are these? We'll just call them the strings. Okay, whatever. String. Okay, so now we have label, and this value. When we have an equals, it means a thing, and I need to know the thing it means. Focal length. No, maybe it's a focal length. Focal length. So there's this case. Yeah. If the operation character is a dash, go to the relevant box, remove the lens with the given label if it is present in the box. Okay. I'm just gonna use an actual map for the boxes here. A map from string to a vector of lenses, which I'm not sure. I guess string. And they might have an order, so I'm gonna leave that as a vector. So map string to vector string. So boxes label move the lens dot exclude or minus equals length. How is so rn1 this label and focal length. After rn equals 1, you add it. Okay. Boxes dot without what is it? Remove, delete. Updated. Yeah, I guess update that label with a new value, which I guess is that thing removed. There's nicer syntax for this somewhere, and I forget what it is. So boxes label dot filter not equal to this thing. Let's put the string in there. Oh no, I'm not gonna do that because the equals and the minus matters. And this depends on if it contains it or not. Yeah. Like this is the order matters. So the focusing power, add up the focusing power of all the lenses. I'm just gonna comment this out for a bit, and we're gonna determine focusing power. Def focusing power lenses, or I don't know, box contents. And does the order matter? From front to back, each lens is shown as its label and focal length in the square brackets. To confirm that all lenses are installed correctly, add up the focusing power of all the lenses. I had a thought that where we insert might matter. Add the focusing power of all the lenses. The focusing power of a single lens is a result of multiplying together. Plus the box number of the lens in that question. The slot number of the lens within the box. Oh wait, boxes are referenced by number? Oh yes, yeah. So right, this is a map from int. Sure. And then updated at the hash. So Rn, 1 times the first slot. Wait, so box 0, 1 because it's box 0, times 1 for the first slot. The slot number of the lens within the box, okay. And this only has 1 in it. Times 1, which is the focal length. Okay. Oh. Look at CM at the end. Okay, so after OT7, this is the last date. Box 0. Okay, I'm starting to understand this now. Box 0, OT7, AB, PC6. Total focusing power of all of these. So you just take the 5 things. Basically, you take their slots. So focal length, box number, focal length, int, and slot number. So, box number times is going to be box number plus 1. This thing might not be completely necessary. We can just get all the values at the end. Yeah, this is a reading problem. I agree. Okay, so we'll get the steps and let's see if we can get the final state. I might do this on the example problem. I think this is a case where I'll need that. Day 15, 2023. Save this as example. And what is it? Here we go. Okay. So there's a string. So the whole string tells you the box number, right? Box. Tells you the box number. Is it based on hashing the label or hashing the whole string? Box is updated. Like, why is there a box 0 being modified when the hash of Rn equals 1 is 30? Hash Rn. Okay, yes, it is just the first part. So take hash of just the label. Box updated hash label. Val box equals hash of the label. Yeah, I'm just gonna call this I. Boxes I, filter not equals label and focal length. And when you add something, so here equals 3, box 3 gets a thing. Here, you just add to the right. Okay, so val I equals hash and label. Boxes update I with. I'm gonna make this a default vector of 0. Plus that to the right exactly. If, hold on, if it's not contained. And if it is already contained, what happens? Yeah, I know, I can't read this fast enough. If it's an equal sign, it'll be followed by a number. Focal length of the lens that needs to go into the relevant box. Be sure to use a label maker to mark the lens with a label. Okay, so you can find it later. Oh, okay. Right, the same label might be used multiple times. There are two possible. If there's already a lens in the box with the same label, place the old lens with the new lens. Put the new lens in its place, not moving any other lenses in the box. Ah, okay. So this is a vector of labels. So this is a vector of string and focal length. And then this filter not so you filter this box. This should be just on the label. So just the first part, 1, not equal to the label. Filling any space by removing the indicated. And move any remaining lenses as far forward in the box as it can go. Okay. So this does that. Wait, how? Required. Oh, yes, yes. This needs to change too. So just give a type. Box is a vector of string and int tuples of labeled lenses. Okay, so map of int to box. Okay, and in this case, we take the box. You see if the box exists. So val box sure. Actually, no, we don't even need to do that. So we have boxes I, and this gets updated. And we need the index of the thing. So that like def insert lens. I'm just gonna do this. Def insert lens into box. We get another box. And let's see, there's gonna be like a label and a focal length. Label string focal length int. So it's not quite that. The box that um, previous lens. So now existing equals boxes.find. One equals label, great. And listing. So if there's none, um, let's get the index of it. So box.indexWhere. Yes. Okay. If it's then we just add it to the right. Otherwise, we update at existing with the same label. And no, we don't add the focal length. We just replace it with a new focal length. Label to the new focal length. If I'd said new, then Copilot would have done that correctly. Okay, now we have insert lens into box of I. Insert lens, boxes I with that label and focal length. Okay, so that works. Focal length that to int. Does focal length get completely ignored in the minus case? Yeah, I guess it does. So like CM minus, yeah, what follows doesn't matter. So I'm like gonna underscore that. Okay, and now final box state equals map.empty and with default value dot with default value vector dot t. And we take step. Oh, hold on. Not inputs, but rather we put boxes here as a left parameter. Right? No, the accumulator. Yeah, boxes is accumulator, so it moves. We'll put that on the left. And we can take strings, not fold left, with empty boxes, whatever. And then final state for each print line. Let's make sure that looks correct. Box state for each print line. So box 0 has rn1 cm2. Box 3, and that box is just empty. Okay. So final box state filter filter 2 is non-empty. And then dot map box number and box, and we just do the focusing power. We're gonna do like a box that's zip with index. So I don't like this. So like box dot zip with index dot map. Okay, and this is the label focal length, and this is a slot number. Does a slot number need to be incremented though? Yeah. So slot number +1, box number +1, and we're just multiplying this. I think I've got it. Times focal length. And what do we call this? Val focusing powers equals that. And we'll make this, we're gonna flat map this. So this is mapping to, yeah. And then val ans2 equals focusing powers, that's sum. In this case, 145. That works. Let's go back to the main problem. 245223. Beautiful. Okay. Not bad. Okay, so I missed some chats. I'm gonna catch up on you here. These descriptions feel like our client tickets. First tell you a fairy tale and put the actual requirements somewhere between. Unfortunately, with no highlighted text. Yeah. Honestly, I think we need like GPT to go into the client tickets and be like, this here, given this is probably what your engineer's gonna do. Is this correct or whatever? Just like cut out some of the crap of like going back and forth. Make the requirements more clear so that they can see it's wrong before they even pass it to us, you know? I'm gonna add this one, so 15 commit and the 2023 day 15 as solved on stream. You know, today felt smoother, minus the what is it? Minus the looking around the problem description. But writing it was pretty straightforward. Nice to have a little break. I'm just gonna do this here. A little bit of cleanup. Get rid of things I don't need. We don't need to see this anymore. Final box state, map.empty, vector.empty. Well, empty box. We're just gonna put this here. This is gonna be like a, yeah, that's fine. So we start with the empty box, and then we do step. There we go. That looks a little bit cleaner. We don't need this code here. I'll just add that cleanup. And I push that to GitHub. So let's He tried that, even building a small LangChain app with Jira integration, but it works so-so depending on a ticket. Uh, well, I don't know. Maybe in the future we can dream. Um, Zara said, "Today I spent a lot of time reading the question and having a hard time understanding it." I know. It was definitely like a reading exercise. Refinement then feels like doing the Say's problem. What do they want? Yeah. Misread at least 5 times. I feel you there. I guess I imagine that people that solved it first like took a gamble. Like the fastest ones were like, oh well, probably this is what we're doing, right? Like for one, it wasn't clear if you're supposed to hash the label or hash the whole string or something like that. Like maybe they just made the guess, okay, we're just gonna have to hash the left side, yada yada. Um, and took a guess, like, okay, this is a hash map. It's called hash map. Oh, Mawixi, thank you for the raid. So we have finished. This is my code here. Oh, welcome, welcome. Were you doing admin code yourself? How was your stream? We were just talking about this problem, how it is it is really just a reading problem. Like the implementation is easy. And my guess was that the people who saw this faster saw like hash map and they're like, this is gonna be sort of like a hash map and took a guess at this, and their guess was right. I went through and like pretty carefully read this, like a lot of back and forth reading. Day 15, yes. Oh, welcome everyone. Thanks for all the chats. Week C is stuck at day 3. But it was fun. Good. Advent code is supposed to be fun. It's like I'm not a lead coder or anything like that. I like Project Euler because it's mathy, but I love Advent code because of the community. Like everyone's solving the problem at the same time, and you have everyone sharing their solutions and comparing. In fact, if any of you have solutions, I'd love to see that. Someone did both parts in 126. Jeez, I didn't even read the first part in 126. How did I do today? So I did the first part in 4 minutes, and it took me another. Oh, this is my first time this year being top 1000. Um, it's been a rougher year for me. I've been like a bit rusty. As top 1000, 1, 2, 3, 4, 5 times last year. But this feels good. I've had a few streams I'd had to cut off early. Yeah, that's a win for me. That's my first. Oh, this so um, last night I was an hour into my stream, and then I had to take care of someone who was sick. So a little emergency came up. I had to stop. And then I logged on. I mean, I had time to think about the problem. But I logged on like an hour before today's problem dropped, hoping I would get this done in time, like before day 15 drops. And I got it with less than 5 minutes to spare. It was a race against the clock, and that was a win for me today. This year's a win for me today. I'm happy. Um, I'm about to check how leaderboards are moving along. If you'd like to join my leaderboard, it's right here. And if you'd like to see any of the code I've just written, this is my GitHub. Um, and of course, anyone who's been here. Uh, geez, like Blue, I'd like to see some of your code, some of your approaches, or Zarn. Um, I don't know if you're in Discord yet, but that's where we can share code, and I'd like to see what you all have. Uh, so for now, I've popped up to 4th. I beat Jan Peter today, which is good. Jan Peter is my target, my rival that's keeping me motivated. Um, we are currently tied on the Scala Center leaderboard. So I wrote this in Scala. Scala Center is doing a big advent of code thing. Um, and I had a slow patch in here where I've lost my lead. Um, one. I was still wait. Day 15. Here we go. I was first for part one. That feels good. I dropped to third for part two. Um, it was definitely a reading exercise, and I was slow at reading. This came smoothly though. It feels good not to be like debugging your code the whole stream. To be fair, Scala is more verbose than most competitive languages. Uh, yes, it is more concise than a lot of production languages. And I might not be providing the best example here. Like when I write Scala code and Python code, Scala gives me more tools to make it concise. So my Scala code is more concise than my Python. And Python's fairly concise. So using my experience as a frame of reference, that's where I'd place it. Um, okay. Oh, Galvabear. Galvabart, thank you for the follow. Uh, there's not much more to look at tonight. So he just rated, but um, I have my library to work on, but it might be nice to get an early night of sleep for once. So, who do we know that's still doing this? I think we should pass this along. But I will be here every night this month. What are we looking for? We're looking for which advent of code. You know what? On that concise, let's look at my last files. We're gonna grep for 2023, and then xargs word count line. Um, these are my solution links for this year, and I'd say like for the most part that's shorter than a lot that I see from other people, except for like a few days that still need to be like really cleaned up. That has like a lot of test code in it, probably. I don't know what I'm averaging. I want to say 30, 40. Yeah, these spikes really ruin the average, whatever that is. um, let's check in on people. How is Alka doing? Have they finished Math Not Pi? I don't think they're working on Advent Code anymore. Um, let's see. Let's do an Advent Code tag.
There's a four.
We can pass it on to Zombie Shoe. See how they're doing.
Most amount of unit tests and integration tests. I'll have this deployed on a web service. You'll be able to hit it on.
Yeah. Zombie Shoot is still working on it. But yeah, let's watch them finish this up. And thanks everyone for stopping by. Thanks again for the raid. I appreciate it. You just missed the show though. And have a good night. Good luck with everyone with Advent Code. So raid zombie. Take care. See you tomorrow. And good luck for the work. It's impressive that you're waking up every morning for having a code. All right, everyone. Good night. Good night.